Yeah, good morning everybody, and once again welcome to Pankaj Sir's Echelon Tutorials. And in this today's session, I'm going to uh, deal with IGCSE 10th grade, okay? And the subject is physics. And today I have chosen to discuss question number 11 and 12 from chapter number 25. The name of the chapter is Stars and Universe, and this is from the book David Seng, the course book that is followed by many of the schools. And this is the third edition, the latest edition. Okay, so from this book, I have picked up from chapter number 25, question number 11 and 12. Okay, so these two questions I'm going to discuss today with you people. Okay, so let us get started. To start with, here we go with the question first. So on the screen, you can see this question number 11 and 12. Now, question number 11 says that imagine that the Milky Way is shrunk down to fit into the space between the Earth and the Sun. On this scale, calculate how far away the following bodies would be from the Earth. And these are the bodies, the different bodies given. Okay. So A is Proxima Centauri, the star which is near to our solar system. And you have to find the distance from Earth of this particular star in kilometers. Then Pluto, again you have to find the distance of Pluto from the Earth in kilometers. Then Sun, you have to find the distance of the Sun from the Earth in meters. And D is you have to find the distance of the Moon from the Earth in centimeters. Okay. Now this question seems to be very tricky. Many of the times students, they get confused. They don't understand what actually the interpretation of the question itself is very tricky. Okay. So if you get the interpretation, if you know how to know what is the question asked actually, okay, literally, then you can answer these questions. Okay. So today I'm going to help you in understanding this question, and I'll solve this question very nicely to see that you people are understanding it. Okay. So basically what he is trying to tell you is the Milky Way, okay, that is the galaxy that we belong to, okay, and this Milky Way, suppose now Milky Way, if you see, actually Milky Way is having a diameter of uh, uh, 1 lakh, 1, 2, 3, 4, 5, 1 lakh light years. Okay, this is the diameter of the Milky Way. So if you go from one end to the other end of the Milky Way, the diameter is 10 raised to 5 light years, or you can say 1 lakh light years. You can say 10 raised to 5 light years. Okay. Now suppose this particular Milky Way is somehow shrunk and fixed into the distance between the Earth. Suppose this is Earth and suppose this is Sun. So suppose this Milky Way is somehow placed or fit into this distance between the Earth and the Sun. Now, what is the distance between the Earth and the Sun? The distance between the Earth and the Sun is 150, okay, million kilometers. So I'll write 150, 1, 2, 3, 4, 5, 6, okay, kilometer. Or this can be written as 15 into 10 raised to 7 kilometers, isn't it? So this is the distance between the Earth and the Sun. So this Milky Way, whose actual distance is 1 lakh light years, which is a very, very, very huge distance. Okay. Somehow this Milky Way, you can imagine that it is shrunk, it has been compressed and placed between this distance between the Earth and the Sun, which actually is 15 into 10 raised to 7 kilometers. With this as the background, you have to solve this question. So this happens to be the situation that they have created in the question. Okay, so the Milky Way has been fit into this distance between the Earth and the Sun. Now on this scale, so you'll have to prepare a scale. So what will be the scale? The scale will be, now this is 10 raised to 5 light years. Okay, but 10 raised to 5 light years, that is the diameter, actual diameter of the Milky Way, has been fit into this particular distance between the Earth and the Sun. So your scale is this 10 raised to 5 light years is equal to 15 into 10 raised to 7 kilometers. This is the scale that they have given you. Okay, with this scale you will have to find out all these distances that are given here, A, B, C, and D. Okay, and all these distances are from the planet Earth. Okay, so one by one we are going to deal with this question. Okay, so first let me do this A question. Okay, so A part of the question. A part of the question says that you have to find the value of the distance from the earth of this particular Proxima Centauri in kilometers. Now first let me tell you what is this Proxima Centauri. Proxima Centauri is sun. Apart from our sun, this is another sun which is nearest to our solar system. Okay, so Proxima Centauri is a sun. Okay, near to our galaxy, that is Milky Way. Okay, and it is 4.2 light years away from the earth. Okay, from the earth, or you can say from our solar system, right? So the actual distance from the earth to this Proxima Centauri, I'll write PC for Proxima Centauri. This distance is 4.2 light years. Okay, but then the question asked is you have to find the distance of this Proxima Centauri. A part of the question, right? This distance, Proxima Centauri in kilometers. Okay, and that too with respect to the scale, because now your Milky Way has been shrunk and it has been put into this space between the earth and the sun. So you have got this scale, so you have to use this scale and you have to find out the distance. Okay, so see how I'm doing it, right? First of all, you will have to write the actual distance of the earth, of the PC, that is Proxima Centauri, from the earth. So you know that the actual distance is 4.2 years. Now what is the scale? The scale is 10 raised to 5 light years. The scale is 10 raised to 5 light years. Okay, is equal to, what is the distance between the sun and the earth? It is 15 into 10 raised to 7 kilometers, right? Now you have to convert this 4.2 light years, or no need of converting. Here there is 10 raised to 5 light year. Below this 10 raised to 5 light year, you will have to write 4.2 light year. Okay. So 4.2 light year will be equal to how much kilometer? Okay, this is nothing but your unitary method. Okay, straightforward question. So with the help of this scale, you are going to find out this distance, that is 4.2 light year, how much it will be in kilometer. So this is a simple mathematical unitary method. So using unitary method, okay, you will get the answer for this distance in kilometer. That is the distance between the earth and the PC. So this will work out to 4.2 multiplied by 15 multiplied by 10 raised to 7 divided by 10 raised to 5. This will be the answer, okay, for this. And this answer will be in kilometers. Now if you work out this, it will be 4.2 into 15 into 10 raised to 7 and 10 raised to 5. So it will work out to 10 raised to 2, okay, kilometer. Then 4.2 into 15 should work out to, let me check my calci, and 4.2 into 15 is working out to 63. So this happens to be 63 into 10 raised to 2 kilometer, which is nothing but 6300 kilometer. So the answer for this A question is, answer is the distance of Proxima Centauri from the earth is 6300 kilometers. Okay, this is 6300 kilometer with respect to this scale. Okay, this scale. So that was the answer for the part A of the question. Now let us check what is the B question. Part B of the question is what? Let us see. Now part B is, you have to find in a similar way what is the distance from the earth of this planet Pluto, and this distance you have to find in kilometers. Okay, So again the same question, similar question, but this time you have to find the distance between the Earth and the Pluto. So let us go for that. So B part of the question, now I am doing it. So B part. B is you have to find the distance between Earth and Pluto. Isn't it? Earth and Pluto. Now this is Earth and suppose this is Pluto, right? Now actual distance between Earth and Pluto is how much you know. Now these are the things, these are the figures, you know, that you should know, and all these figures you will find in your textbook, in your course book. Okay, so the actual distance between the Earth and the Pluto happens to be 40 times the distance between the Sun and the Earth. And what is the distance between the Sun and the Earth? It is 15 into 10 raised to 7 kilometers. So the distance between the Earth and the Pluto happens to be 40 into 15 into 10 raised to 7 kilometers, right? Now this distance you have to convert it according to the scale. So the scale again is, scale is 10 raised to 5 light year is equal to 15 into 10 raised to 7 kilometer, right? Okay. Now this much kilometer you will have to find. Okay, you have to convert it according to the scale. So first what you do, this particular distance in kilometer, you convert it into light year. Okay, so convert this into light year. So this is the scale. Okay, this will be using later. Now what I'm going to do is this distance which is given between Earth and Pluto in kilometer, that I'll convert into light year. So I know that 1 light year is equal to 9.5 times 10 raised to 7 kilometers. Okay, am I right? No, 9.5 times 10, this is also given in your book. It is 10 raised to 12 kilometers, right? 1 light year is equal to 9.5 into 10 raised to 12 kilometers. Okay, therefore this 40 times 15 times 10 raised to 7 kilometer, this will be how much, how many light year? Again you are going to use unitary method, and the answer for this will be 40 times 15 times 10 raised to 7 divided by 9.5 times 10 raised to 12, and this answer will be in light years. So this will work out to, this 10 raised to 7 upon 10 raised to 12 will be 10 raised to minus 5, 7 minus 12 is 5. Okay, and this 40 into 15 divided by 9.5 should work out to actually 63.2. Okay, so this many light years. So 63.2 into 10 raised to minus 5 light years is the value for this many kilometers. Okay, so this is equivalent. Now what I'm going to do is, now I'm going to use this scale. Okay, so the scale says that 10 raised to 5 light years is equal to 15 into 10 raised to 7 kilometers. Therefore, we have got this much light year, that is 63.2 into 10 raised to minus 5 light year. This will be equal to how many kilometers? Okay. So now again, you'll have to find out this answer. So you'll get 63.2 into 10 raised to minus 5 into 15 into 10 raised to 7 whole divided by this 10 raised to 5, and now the answer you will be getting is in kilometer. Now this should work out to 10 raised to 7 and 10 raised to minus 5. Okay, so I'll do this 63.2 into 15, I'll do separately, and minus 5 plus 7 is 2, and 2 minus 5 is minus 3, so this will work out to 10 raised to minus 3. Okay, and 63.2 into 15 should work out to how much? 63 point, let me see that, 63.2 multiplied by 15, it works out to 948. Okay, so this is 948, okay, into 10 raised to minus 3 kilometers, right? So the answer will be how much? It will be 948 10 raised to minus 3 can be written as 948 upon 10 raised to 3. Okay. This will work out to 0.948 kilometer. Now, if you round it to 2 SF, you will get 0.95 kilometer. So this is the answer, 0.95 kilometer. Okay. So your answer for B is the distance between the Earth and Pluto will be 0.95 kilometer according to this scale that is given. Okay. So that was B part of the question. Let us go for C. Right. Now let us see what is C question first. Now C question says that you have to find out the distance of the sun from the earth, but this time you have to find out the distance in meters. Okay, what you have to do? You have to find the distance of the sun from the earth, okay, in meters, right? So this will be doing in this question number C. So let us do that. So this time you have to find the distance in meters. Okay, so C part of the question is, okay, distance between earth and the sun in meters. Okay, you have to find in meters, right? Chalo, how we are going to do this? So again, the scale that we are going to use is 10 raised to 5 light year, that is the Milky Way, has been fit into the distance between the sun and the earth, which is how much? It is 15 into 10 raised to 7 kilometer. This is the scale. Okay. Now, this distance between the earth and the sun, you have to find out. Okay, so actual distance between the earth and the sun is how much? It is uh, 15 into 10 raised to 7 kilometer. This is the distance between the earth and the sun. Okay, now this distance you will have to convert it into light years, isn't it? So how we'll do it this? 1 light year is equal to, we know this equation, 1 light year is equal to 9.5 times 10 raised to 12 kilometer, isn't it? This we know. Therefore, this many kilometer. Now below the kilometer, you'll have to write this on this side, right hand side. 15 into 10 raised to 7 kilometer will be equal to how many light year? Okay. So now again using your unitary method, okay, you will get 15 into 10 raised to 7 times 1 divided by 9.5 times 10 raised to 12, and this will be now in light year. The answer will be in light year. So this will be equal to 10 raised to 7 upon 10 raised to 12 will work out to 7 minus 12 is minus 5, 10 raised to minus 5, and 15 upon 9.5 should work out to 1.6. So this many light years you are getting. So this actual distance between the sun and the earth, which was 15 into 10 raised to 7 kilometer, I have converted into light years. Now I am going to use this scale. Now what is my scale? The scale is 10 raised to 5 light years is equal to 15 into 10 raised to 7 kilometers. Okay. Now, this many light years, that is 1.6 into 10 raised to minus 5 light years will be equal to how many kilometers, isn't it? So now I'll get the answer in kilometers, but mind you, you have to get the answer in meters. Okay. So first let us get the answer in kilometers by converting according to this scale. So now we are using this scale and we are doing it. Okay. So the answer will be 1.6 into 10 raised to minus 5 into 15 into 10 raised to 7, that is this into this, divided by this quantity 10 raised to 5, and this will be the answer in kilometers. Okay. So the converted answer, the conversion according to the scale. Now this should work out to now 10 raised to minus 5 and 10 raised to 7 will be how much, you know? It will be 10 raised to 2, and 10 raised to 2 upon 10 raised to 5 will be 10 raised to minus 3. So all these 10 powers you can simplify to 10 raised to minus 3, and you are left with 1.6 into 15, and 1.6 into 15 works out to 24. So this many kilometer is the answer. This will be the distance between the sun and the earth. Okay, the converted answer. Okay, not the actual one, converted one according to the scale. But then he has told you the answer should be in meters. Okay, the answer for the C has to be in meters. The distance between the earth and sun should be in meters. So this 24 into 10 raised to minus 3, I can write 24 upon 10 raised to 3 kilometer, which can be written as 0.024 kilometers, right? And in meters, if you want the answer, you will multiply by 10 raised to 3. So it will be 0.024 times 10 raised to 3 meters. Okay, this will work out to 24 meters. So this is your answer for C. So answer for C will be, the distance between the sun and the earth is equal to 24 meters according to that scale. Okay, so that was C part of the question that we did, and now let us do the D part of the question. And D question is, you have to find the distance between the moon and the earth. Okay, moon and the earth this time, and that too in centimeters, right? So let us come to this D part of the question. So here we go. D. D is, you have to find the distance between between the moon and the earth this time. Okay. This time you have to find the distance between moon and the earth. Okay. This distance according to the scale, right? Now the actual distance between the moon and the earth is 390,000 kilometers. This is the actual distance between the moon and the earth, right? You have to convert this according to our scale. Okay, and you have to find the distance in centimeter, right? So again, the scale that we are going to use will be 10 raised to 5 light years, that is the diameter of the Milky Way, equal to 15 into 10 raised to 7 kilometer. Now why I'm writing this? Because the Milky Way, whose diameter is 10 raised to 5 light years, has been shrinked and fit into this particular distance between the sun and the this thing. Okay, sun and the earth. Okay, which is 15 into 10 raised to 7 kilometer. This scale we are going to use. Now this 390,000 kilometer, first that will convert into light years. So we know that 1 light year is equal to 9.5 times 10 raised to 1 light year is 9.5 times 10 raised to 12 kilometers, isn't it? So 390,000 kilometer, this is the distance between the moon and the earth. This will be how many light years? So again, using your unitary method, you will get the answer, and the answer will be 390,000 into 1 divided by 9.5 into 10 raised to 12, and this answer will be in light years. So this distance between the moon and the earth, I am just converting into light year. So this should work out to 39 into 10 raised to 4 divided by 9.5 into 10 raised to 12, that is equal to 10 raised to 4 upon 10 raised to 12 will be 10 raised to minus 8, and 39 upon 9.5 should work out to, I think, how much, let me check. Yeah, 39 upon 9.5, isn't it? Should work out to, I think, 4.1, right? it is 4.105, but I'll take only up to 2 SF. So 4.1 into 10 raised to minus 8 light years. Got it? Now this I am going to use in this scale. So my scale is 10 raised to 5 light year equal to 15 into 10 raised to 7 kilometer. Therefore, 4.1 into 10 raised to minus 8 light year will be equal to how many kilometers? So now, using this scale, my distance will be 4.1. Okay, second, it will be 4.1 times 10 raised to minus 8 times 15 times 10 raised to 7 whole divided by 10 raised to 5. And now the answer will be in kilometers. Mind you, we have to get the answer in centimeters. Now we'll get the answer in kilometers. Okay. So let us first get the answer in kilometers. This should work out to 10 raised to minus 10 raised to 7. That is 10 raised to minus 1. And minus 1 minus 5 will be 10 raised to minus 6. Right. So uh, one second. Minus 8 and okay. We'll first work out this 4.1 into 15. Okay. So 4.1 into 15 works out to 61.1 times. Now this is minus 8 and 7, right? So minus 8 and 7. One second. Minus 8 and 7. Okay. Let me check this 4.1 into 15. One second. Uh, yeah, I want to check it. Yeah. Now 4.1 into 15. Let me do that. Okay. 4.1 times 15 is 61.5. That's correct. Okay. So 4.1 into 15 is 61.5. And this will be minus 8 and plus 7 will be 10 is to minus 1. And this will be minus 1 and upon 10 is to 5. Right. Okay. This will be in kilometer. So this should work out to 61.5 divided by 10 will be 6.15 divided by 10 raised to 5. This many kilometers, isn't it? Now, I want to convert this into centimeter. So this 6.15, can I write as 6.2? Okay. Upon 10 raised to 5. Okay. And this kilometer, if I want to convert it into centimeters, I'll have to multiply by, to make it into meter, 10 raised to 3, to make it into centimeter, 100 again I'll have to multiply. So it will be 10 raised to 5 centimeter, right? Now this 10 is to 5, 10 is to 5 gets cut, and the answer you get in centimeter is 6.2 centimeter. So my final answer is 6.2 centimeter. So answer for D is the distance between the moon and the earth is 6.2 centimeters. Okay. Now you will be imagining that these are so weird answers. How can the distance between moon and earth which can ever be 6.2 centimeter? Now all these answers that we have got, these are nothing but imagining that the Milky Way has been shrunk and it has been put into a distance which is between the earth and the sun, and Milky Way is a very very huge distance. Okay, it is 10 to 5 light years. That has been fit into a smaller distance between the earth and the sun, and according to that scale we have got all these answers. Okay, so that is why these answers are, you may feel that they are weird, but then nothing weird about it. These are the converted answers. Now that was question number 11 which I have completed. Now question number 12 I will have to do with you. Okay, question number 12. Now let us see what is question number 12 first of all. Now question number 12 says that, here we go, question number 12. Okay, question number 12 says that write a sentence or two comparing your answers in question number 11. So all these four answers A, B, C, D that we got in question number 11, the answers that we got, that we have to compare with the length of a pencil, the length of a cricket pitch, which is around 20 meters. Then you can compare with the 400-meter athletic track, and you can compare with the radius of the earth, which is 6400 kilometers. Okay, so these four things we are given, and these four things we have to compare. Okay, so first let us take this answer for this A. The A part of the question ka answer we got 6300 kilometers. Okay, so this 6300 kilometer can be compared with this 6400 kilometer, that is the radius of the earth. So my 12th ka answer will be the comparison. I'll start with A. Okay, so the distance between the earth and the sun, okay, which we got 6300 kilometer, is almost or is almost equal to the radius of the earth. Now radius of the earth is 64 kilometers. Okay, 6400 kilometers, right? So 6300 kilometers is just slightly less than 6400 kilometers. So you can say that the distance between the earth and the sun, that is the converted distance according to the scale, is almost equal to the radius of the earth. Okay, then B was what? The distance between the Pluto and the earth, and we got the answer as 0.95 kilometer. So this can be compared with what? 0.95 kilometer. Now nothing is given here in kilometers. Okay, so what we can do, okay, kilometers can be converted into meters, right? Okay, chalo. Now this distance between earth and Pluto, which we got as how much? 900 and how much we got the answer? It was 0.95 kilometers. Okay, so if you convert it into meters, it will be 950 meters, isn't it? 950 meters. So the distance between the earth and the Pluto, which is 950 meters according to the converted scale, okay, is almost same as 2 laps of 400 meter. Now see, 400 meter ka 2 laps means it will be 800 meter. So can you see this 950 meter is almost equal to 800 meter. 2 laps of 400 meter athletic track, right? So the distance between earth and Pluto can be compared with the 2 laps of the track, the athletic track. Now C part of the question, we got the answer as 24 meters. Now 24 meters can be compared with what? So what was that 24 meters? 24 meters was the distance between the earth and the sun. Can you see this? Distance between the earth and the sun in meters. Okay. So the distance between earth and sun in meters, how much we got? 24 meters, is same as, okay, almost same as the pitch of the cricket. Okay, pitch of the cricket is how much? It is 20 meters, right? So this is almost 24 meters. The pitch of the cricket they have given you as 20 meters, right? So you can compare that with that. And D part of the answer, you can see here the distance between the moon and the earth is 6.2 centimeter. So this distance between moon and earth, which we got as 6.2 centimeter, this can be compared with, now normally the pencil, you know, a full-fledged pencil, a new pencil is around 18 centimeter. So if you consider this as 6, rounding karke 6 centimeter, So it will be 3 times. So this distance between the moon and the earth can be compared with 3 times the distance, 3 times the length of the pencil. Okay, 3 times the length of the pencil. Now normally the length of a pencil happens to be 18 centimeter. Okay, so this distance between moon and earth, which was 6.2 centimeter, is roughly equal to 3 times the length of the pencil. Okay, sorry, this yeah, so the distance between the moon and earth will be 3 times the length of the pencil. So pencil will also be less. Okay, this moon distance between the moon and the earth will be less than even the pencil. Pencil will be 3 times bigger than the distance of the moon and the earth, between the moon and the earth. Okay, so this is how you can answer this question number 12, right? This is the comparison of all the 4 values you got in that question number 11, A, B, C, D. You are comparing that with the pencil, and then you compared with the cricket pitch, then you compared with the athletic track, and then you compared it with the radius of the earth. Okay, so this was question number 12 and question number 11, both from the Davidson book, the latest edition, the third edition, from chapter number 25. And I think now many of the students will find it really easy, and they will understand this question number 11 and 12. So that's all for today. If you happen to like my video, please subscribe to my channel. Okay, and I'll be motivated to make more and more such videos. So that's all for today. So see you in the next video sometime. Bye, take care all of you.